relationships. So you've learned about angles before, but really here we're going to be focusing on angle relationships. That's how two angles relate to each other. Before we jump into that, we just want to talk about what an angle is and how to name it. So an angle, in general, is two rays or lines that meet at a common endpoint known as a vertex. This is that vertex. That's one line. That's another line. Really, they're rays, but that distinction is not that important right now. It's really just important that you know that an angle is made up of two different lines. It's not either line, it's both of them put together, and it's really the space that's in between. It's that rotation from one line to the next line. How far is it from there to there? So, we can talk about this as angle 1. This little sign, that's the angle symbol. So that's angle 1. Sometimes it's not that convenient, though. This is just labeled as angle 1. Sometimes we have to talk about it as the three letters that are labeling the points that connect to form that angle. So we'd say it's angle QRS or angle SRQ. So that's just a way for us to talk about that space that's in between. So that's one angle. When we talk about angle relationships, we're talking about how two angles are related to each other. So there's the four vocab words that you just need to be familiar with. The first one is adjacent. Adjacent angles are angles that are non-overlapping and they share a common side and a common vertex. The simplest way to say that is that they're right next to each other. And I don't just mean generally on the paper that they're next to each other. I mean that they're directly next to each other, and this is really what we're looking for, a common side and a common vertex. So I'm looking for an angle that's adjacent to FHG. When I name that angle, I'm really just connecting the dots. F to H to G is that space there. And you can see it has that little box there. That just means that that's a right angle. So that's 90 degrees. That's not so super important right now. We're looking for something that's adjacent to that. Adjacent means directly next to it, which means it shares a common side, so this has to be a part of it. That's the common side. And I'm going to use this one as the second ray of that angle. You actually didn't have to use that one, but I'm just going to choose this one. So I'm saying these two angles are adjacent to each other. They're right next to each other. They have a common vertex, there it's H, and they have this common side of GH. So angle GHI is adjacent to FHG. It is way simpler when they're labeled with numbers like this. Angle 6 is adjacent to, right next to angle 6 is angle 5. On the other side of angle 6 is angle 8. So angle 8 and angle 5 are both adjacent to angle 6. Angle 7 is across from it. That's not next to it. Even though they connect at that same vertex, they don't have the same common side. 5 shares this side, 8 shares that side. Vertical angles are across from each other. They are non-adjacent, they can't be adjacent to each other, and they share a common vertex. So anytime you see an X like this, cross like that, on opposite sides, those are called vertical angles. These two are vertical, and actually these two are also vertical angles. Vertical angles are always equal in measure. So if I said that this is 85, across from that also has to be 85. This would have to be 95, forcing this to be 95. Across from each other, they are called vertical angles, and they are adjacent. Oh, sorry, yikes. They are equal to each other. So angle 1 and blank are vertical. Angle 1 and angle 3 are vertical. They are directly across from each other. Angle 2 is vertical to angle 4. It's just on opposite sides of these two crossing lines. Alright, if angle 2 has a measure of 40 degrees, what other angle measures 40 degrees? It's just going to be the one that's on the opposite side. The vertical angle to angle 2 is angle 3. That also has to be 40 degrees, so I'm going to say angle 3. Alright, two angles that have a sum of 90 degrees are called complementary. These are words that you definitely have to memorize. You've got to distinguish between complementary and supplementary. Complementary add up to 90. Supplementary are going to add up to 180. Easy way to remember that, if you put a line right here, the letter C turns into a 9, and then you have a 0 next to that. That forms the number 90. Complementary are always adding up to 90. 27 plus 63. That's 90 degrees. In a picture, this will look like a perfect corner. So I'm kind of just squeezing these next to each other. So that's the 63-degree angle, that's the 27. These makes them adjacent. These angles are not adjacent to each other. They don't have that common side. They're not a part of the same picture at all, really. We call those complementary because they add up to 90. These two, we would say they're complementary and they're adjacent to each other. Right, so we're trying to name a pair of complementary angles here. So to form a 90-degree angle is to form a perfect corner like this. This angle by itself is already 90 degrees. Complementary angles means two angles put together to form 90 degrees. So it can't be one of these. It can't include that at all. That's already 90 by itself. It really has to be the other side of this. That's the 90-degree angle that we're talking about. This is one angle. This is the second one. Yikes, I'm going to try that one again. This angle, the blue one, and this angle, the green one, together, they're forming that red 90-degree angle. So GHI and angle IHJ are complementary. Because together, they make a perfect 90-degree angle. If we know that angles are complementary, we know that they add up to 90. The angles below are 90 degrees. So we know that those two put together, we know that x plus 75 adds up to 90. I don't know what's going on there. This is not writing at all. Alright, let's try that again. We know that these two put together are complementary, so they have to add up to 90. So I'm going to just label that as an equation. X plus 75 equals 90. This might be overkill right now, but later there are going to be expressions in here that we don't know. We're going to have to set up these kinds of equations. So I'm just going to write it as an equation for practice right now. And it's going to make it clear how we have to solve for x here. We know that they're adding together to get us 90 as a total, so we're going to subtract 75 from both sides. So we'd find out that x is 15 degrees. Because 15 plus 75 adds up to a 90-degree angle. Supplementary angles are adding up to a sum of 180 degrees. So these two together, 60 plus 120, that adds up to 180. As a picture, it's going to look like this. When we put them together, because they're going to make a straight line. That's 180 degrees straight across. So we're going to name a pair of supplementary angles. So we need to make a straight line. We're making this straight line, FJ, with two angles. I'm going to split it here. So I'm going to label this green angle and this red angle as my two angles that are supplementary. So IHJ and FHI are supplementary because they form that straight line. When we put this together with this, they form that straight line. H and S are supplementary. What's the measure of S? Well, if I know that they're supplementary, I'm going to call this one X. I'm going to say X plus 35. I know they're supplementary, so I know they add up to 180. So I can subtract 35 from both sides. And that gives me 145 for the value of X. 145 plus 35 adds up to that 180. Alright, here we're going to talk about just how to describe these angles. So angle N and angle F. Could also say this is M and P or EFG, but this is just labeling it by its vertex. Those two, 36 plus 54, adds up to 90. They're not next to each other. I mean, generally on the page they are next to each other, but they're not sharing that common side. They're not directly squeezed next to each other, so they're not adjacent, they're not across from each other, they're not adding up to 180, they're just adding up to 90. They are complementary. All right, AHB, this angle, AHB, and FEH, F to E to H. That angle and that angle. They are directly across from each other. So we could say that those are vertical angles. They might be complementary. It doesn't look like they are. They might add up to 90, but we can't be certain of that. They can never be these two at the same time. They can't be next to each other and across from each other. BHC, B to H to C, and CHD. Those two angles together, they make that corner. So this angle and this angle are complementary. They're also directly next to each other. They share this common side, and they share that vertex. Those are adjacent. FHC and CHB. This angle and this angle together, they're forming this line F to B all the way across. They're forming straight lines, so they are supplementary. They're also right next to each other. They share that common side, so they're adjacent. Angles A and B on number 3 are just adjacent. They are right next to each other. They're not making a straight line. They're not making a perfect corner. They're not across from each other. They are just adjacent. Right, angle A and angle B are supplementary. Angle A is the supplement of angle B, so they're supplementary. That means they're going to add up to 180. If angle A is 108, what's the measure of angle B? So I know that x plus 108 adds up to 180. I can subtract 108 from both sides and find out that x is 72 degrees. Angle B and this 29-degree angle, together, they're forming this perfect corner. So together, they're adding up to 90 degrees. So B plus 29 adds up to 90. So you can subtract 29 from both sides, and you get that B is 61 degrees. Measure of angle Y. Y and the 76-degree angle are directly across from each other. They have to be identical. Almost no math involved. You just have to recognize that those are the same. That angle and that angle have to be exactly the same. Angle 1 and angle 2 are complementary angles, so they add up to 90. Angle 1 is 52 degrees. Find the measure of angle 2. So I'm going to call this x and say x plus 52 adds up to 90, and then subtract 52 from both sides and find out that x is 38 degrees. Angle B and this 49-degree angle, together they're making this straight line. They're making a straight line, which is a total of 180 degrees. So B plus 49 equals 180. Subtract 49 and get the angle B has to be 131 degrees. Rectangle PQRS. Rectangle has to have 4 right angles. So that means that's 90 degrees altogether. So x plus 47 equals 90. We're going to subtract 47 from both sides and get that x is 43. Last one together. The streets shown intersect to create these 5 angles. Duke Road is perpendicular to Mason Lane. Perpendicular means they are meeting at a 90-degree angle. So this is a right angle. This is also a right angle. They're hitting each other at a perfect corner of 90 degrees. Angle 1 is 44 degrees. We want to find angle 3 and angle 4. Can't directly find those, actually. We're going to have to find angle 2 first, really. So I know that angle 2 and angle 4 are vertical angles. Those are going to be the same. So if I can find angle 2, I can find angle 4. Those are going to be the same. That is a perfect corner, so I know that angle, I'm going to call this one x, angle 2 plus 44 equals 90. So angle 2 has to be 46 degrees. Angle 2 and angle 4 are vertical angles. They're directly across from each other. They have to be the same, so angle 4 is also 46. If that's 46 degrees, and together it forms a straight line with angle 4, these two put together make that straight line. You can see angle 3 extends that way, angle 4 completes the straight line. They have to add up to 180, so x plus 46 adds up to 180. So let's subtract 46 from both sides and find out that angle 3 is 134.